Okay, recording is on. Go ahead.
Thanks, Tim. This session is about the message prioritization and clustering coordination. We are going to discuss about the cluster coordination, message prioritization, mostly locking and distributed stores. Okay, all the concept around all these important concepts, important information. I want to take this session. It's more interactive. It's not like a more design session. Okay, so whatever we have implemented, whatever that experimental implementation we have done for message prioritization, NATs, and all those implementation, we are going to discuss in this session, as well as we are going to find out what all the problems that we want to solve, and whether we solved completely or not, and how we want to take it further. Okay, in terms of production. How we want to take it to the production. Okay, right now it is experimental, so how we want to take it to production. That's all. Okay, let me put this topic first. How I want to first let me explain that what is lock and what kind of lock that we are trying to look into that, and after then a little bit about that atomics I will try to explain, and after then I will try to include. I will talk about the small details about the NATs messaging system, and after then I will talk about the prioritization, how we are trying to handle the prioritization, back pressure, and along with the combining atomics and NATs and other frameworks utilities that we have created. Okay. So first, let me explain that lock. Okay, lock. Assume that what is lock in this case. Okay, here we are trying to talk about a completely distributed lock. Say for an example, you have a device, and then you have a container, okay, or replica. Assume that in this case it's like you have a replica of the same code. Assume that the replica, it's a 3 replica. You are having that, which tries to, or on top of that, in front of that, you have a load balancer. So what happens? Okay, and that load balancer, according to the load balancer concept, okay, load balancer is just to distribute this message, okay, based on that load. It may land in one replica, the replica is 0 or replica 1 or replica 2, okay, and back on the back side of that, all the replicas, or assume that it's like some piece of logic, okay, we have a common device, okay, assume that it's a device. Say for an example, the first replica receives that message of user information, and then the second replica receives the message for license information, okay, and then third replica receives that message for different, okay, at a point of time. So what happens? We are in position to just first sequence that, okay. So we want to tell that, okay, whoever receives that first, it should not go and hit that device. So we need some mechanism to understand that message and try to look into that other replica, whether they are trying to process a different message for the same device. If they are trying to process that different message with respect to the same device, then we need to tell that, hold on please, I am processing certain information, I will complete that processing with respect to device, and after then I will give a handle to you so that you can process that second information, so that it will be considered as the latest one. Okay, I pass it here to understand this information or this kind of a scenario first. Okay, just try to visualize this kind of scenario. Then you could understand that what I am trying to speak about in later point of time. Okay, whether this is clear, this kind of scenario is very clear, or I want to repeat it again.
I think it makes sense.
Thanks a lot. Yeah. Who is that? It's a Sebastian, or who is that?
Yeah. Yes.
Okay.
Sebastian.
So exactly. So what's the thing is? So we are in position to solve this issue. Okay. So one, in terms of sequencing. Okay. Say for an example, even though you are trying to receive that message in multiple replicas, first thing is we want to sequence that message. Okay. That is one important thing that we have that. And then second important case is like aggregation. Aggregation means we want to aggregate that message. Say for an example, you may get messages with a multiple requests, but to the device we want to consolidate, or we want to aggregate all those messages into a single message, and then we want to send to that particular devices. Okay, that is another scenario. And another important scenario, it's like a back pressure scenario. Back pressure scenario, it's basically whenever we are trying to get a message, and then suppose for an example, the device should accept one message at a time. Okay, even in a cloud world, we can process that message in a parallel because of our cloud infrastructure, replicas and containers. We can do that, but sometimes what's the thing is the physical device may not process the multiple requests, so it has to go in a sequential way. So what we need to do, we need to sequence and back pressure, apply the back pressure, okay, on the device. Basically, device may take a one request at a time, and after the completion of the request, then only we want to send that second request. So that's similar to that back pressure concept, okay. So we want, based on that device handling, how much load device can handle, so we want to throttle down the request to that particular device. So that is another use case. So there are so many use cases coming into this. So not a simple use case. So we have a lot of use cases. Since CDS it's a powerful, which solved all the other issues. Okay, all the other issues of templating and then all those things. Now we are concentrating on that, on the real use case, how it can optimize and give value when other compared to that other controllers right now not doing. Okay, so that is the reason
Brenda?
we yeah, go ahead please.
Question. When you're mentioning back pressure, ultimately, is the implementation going to be just serialization? It's like you want to lock a resource, which could be like a PNF, and you only want one request to happen at the same time, even though you have multiple requests from different, worker. Is that because back pressure means, okay, I can still execute like 3, but at the same time, but I don't want to go to 4 to overload the network device, right? Or do you mean by back pressure in terms of, okay, there's only going to be one request on one device at a time and all the rest will be queued? Is that, or you really want like, okay, I can have 3 at the same time but not 4? So what's your idea behind back pressure?
Okay, there are multiple definitions for back pressure. So in this case, okay, just try to explain that right now. What I'm trying to think of, I'm trying to think of the back pressure in a device, assuming that that device can handle only n requests at a time, n parallel requests at a time. So it may not handle more than n parallel requests at a time. So it means like, okay, I don't want to delegate that n. I don't want to pump or 100 requests at a time to the particular device and the device to manage that. Before that itself, I want to manage myself with the configuration. Okay, with the configuration, I know that that device can handle only one request at a time. So that with that configuration, I can manage, or I can, it's like my application, that CDS controller application itself manages the request, okay, sent to the device in that manner, instead of sending completely to the device and device to handle that. Okay, so, you get this point, right?
Okay. Yeah, so basically you could have a configuration, as you say, n, and n could differ based on what? Is it per configuration, per device, or?
Per device.
Per device. Okay, so per device you could control, okay, I only want 1 for that device, and I could have 3 for that device, but not 4 and stuff like that.
Yeah, exactly. So it depends on device to
Okay. Okay.
So I think I dumped many use cases in a single point or a single explanation. Okay. So this is a use case really we are trying to solve. Okay. And another use case, I combined that another use case, that OLX use case also. So we want to say that, but there is a catch in that what's the thing is, even I want to discuss further, okay, why we are trying to do that, but I will try to explain this use case also. So we want to have another use case. Okay, say for an example, for a particular blueprint and a particular action and a particular request ID, okay, you should not process the 2 different requests. Okay, so either it may be a combination of blueprint name, blueprint version, and action, or it may be a combination of a blueprint name, a version, action, and request ID. Okay, it's like at what level you want to do that locking, or what level you want to control the multiple replicas to process. You want to control that replicas to process. So that is another important use case. Okay, so locking, with that locking, you can take that locking to any level. Either you can take that locking to any key level, or you can take that locking to a device level, or you can take that locking to any of our blueprint actions level. Okay, irrespective of the case. Okay, so it's like a general implementation. You can apply it anywhere to do that locking. in order to make sure that the replicas or just neighboring parallel processing should not, or distributed processing should not override whatever you are trying to do and mess with that whatever you are trying to do. Okay, so that is a high level concept. Okay. Now, how we are going to achieve that? So for that, what's the thing is, we need a first cluster coordination or container to container communication. Just I think it's like now coming into the cloud solution. Okay, now we talk about, earlier we talked about the business solution, business problem. Now we talk about cloud solution and cloud. So right now we don't have any control. Okay, so right now the control, we don't have any control. So by default, no, most of the applications works in an independent way. Only in certain cases we may need that, and certain people, they may use the database locking, but database locking, it's not that efficient. Okay, it's a performance issues associated with that, and fencing also, it's not properly defined. There are so many use cases, even that releasing that lock and then notifying that lock. Okay, all those things, it's not properly managed. Okay, so and that is another important problem with the database locking, but it works in a certain case. Okay, but not with effective and complete overall solution perspective or a complete end-to-end.
It only works. It only works in the database case, locking of the database. It doesn't work for device, right? So.
Exactly, and business logic. Okay, based on your business logic, if you are trying to define a lock with that which is not respect to the particular data, then it won't work. So that is the reason. No, we need a different architecture or a different kind of APIs or components or infrastructure that we need to solve this issue. Okay, there are so many frameworks already available. Okay, one is Copycat, Hazel's. Okay, mostly we can solve with the distributed store also. This kind of use cases we can solve with distributed store, but the distributed store has a certain limitations also. So we have so many things like Redis. Okay, distributed cache. Okay, we can have a Redis framework, and with the distributed cache we can have that, and then we can have a Zookeeper, we can have that, and then Hazelcase, and then Copycat. So many frameworks are there. But the problem, all those things, it's like, no, each one has its own advantage and a disadvantage. Okay, one good example, let me take that Redis. Redis has it's trying to solve this the same issue, but the problem is like it needs like some data store. Okay, so we want to build up some data store. So that is a problem with Redis. But other than that, we have that, and moreover, the license is not under Apache 2 license. That is another important thing. Okay, and coming back to that, Zookeeper provides a distributed locking mechanism, okay, in a centralized way, not inside that application. So it means you want to run or spin up a separate instance for that Zookeeper, and then you want to connect to the Zookeeper. All the clients has to connect to the Zookeeper, and moreover, it's like you want to connect to that Zookeeper and release a lock. There is a network performance issue, and certain cases it's like a communication protocol. It's not implemented there, and moreover, it provides only low-level APIs, not like application-level API. Okay, so that we can directly use and do that. Okay, and most of the fine-tuning parameters, it is not there. And when it comes to that multiple raft performance kind of architecture, so Zookeeper doesn't provide that. Okay, that is a problem with that Zookeeper. Okay, now next, the important thing, it's like I'm trying to use that ONOS project. Okay, this is another important API called Atomics, which is a ONOS project, which is more related to our controller. Okay, so they are also they have their ONOS controller. Okay, and similarly we are also having our own ODL controller, and then other series. Now it's a series controller we have that. So even everywhere we have the problem. This problem, it's everywhere, not only in our domain or telecom domain space. It's everywhere. Even in ordering space also we have that, or even all spaces. It means like now once you are trying to go with a cloud native kind of solution, then definitely you will have this problem. Okay. Now, next important thing. Okay, so that we have chosen that Atomics. Atomics has a multiple flavors and multiple implementations. One important thing. What really that I'm trying to look in this case, or to solve this issue, it's like one important thing. It's like a distributed locking. So it has a concept called distributed locking, and it has so many other important concepts like semaphore, mutex. Okay, and another important thing that I'm trying to look into the distributed data store. Let me explain the distributed data store later point of time, but right now it is not important in this case. Okay. One important thing right now we are talking about the distributed logging. So what it is trying to do, okay, so along with that all the containers, what we want to do, this container, we will tell that, okay, so just we want to provide the configuration stating that, okay, we are all clients. Say for an example, if we are trying to create a prioritization application, so it means like the prioritization application has 3 instances, assume the 3 replicas. So it means 3 replicas forms a cluster. So it means with that atomics, with just only passing that the neighbor replica's address, okay, replica's address to the all the replicas. So it means like it forms an internal cluster called prioritization cluster, or even the CDS controllers, blueprint processor cluster. So it can form that. And another good thing about that atomics, it's like you can create a multiple clusters. Say for an example, one blueprint processor cluster, and then you can have another cluster called the resource resolution. Say assume that you are trying to separate a resource resolution as a separate microservice. So you can form a resource resolution a microservice cluster, and then you can also form a different cluster. So you can make all the 3 clusters to talk to each other also, So it means like I can form an application cluster also. I can form a even CDS cluster. CDS cluster means the entire group of all these applications as a cluster also. And then between that itself, I can make a log. So it means like we can't only make that log between CDS application or prioritization. We can have a log throughout that all this thing if it is a part of the cluster. Okay, any one of that node from the cluster, it's a part of there. Okay. So what I'm trying to say, it's like, so how it works, it means like it forms a cluster. So in that case, if you are trying to create a log, so before executing a certain function, what I'm going to say that I'm going to execute this function. So that functions may be dependent on device or certain IDs or certain correlation or certain things. So what I will do, I will try to create a log with that name called blueprint name and blueprint version and blueprint action. So in that case, if I try to create a log and then if I try to proceed, okay, so it means like we have a piece of code in all the 3, we will have the same piece of code. So it means like before executing a certain function, it tries to achieve a log, it tries to get a log. Okay. And what happens if my peer already acquired a log for that particular ID, then I may not execute that. So unless if that particular process executes completely, then only I will be in position to execute that. So by that time, that will be in a wait state. Even though if it hits, and even though if it receives a message from a load balancer perspective, if it tries to receive a message, at that point time, okay, it won't execute that. Parallel processing or the neighboring one, it won't execute unless whoever acquired the log first execution completes. Okay. So what happens before, if you feel that, okay, someone should not execute while I'm performing a certain piece of logic, so in that case you are going to create a log. I will show that example. That's just I'm trying to give an explanation first. Okay, so what I'm trying to, how it is trying to achieve. Okay, so it tries to create a log, and then after that it tries to execute a piece of logic, and then it releases a log. So in that case, after then the second one will try to execute. So this kind of use cases mostly we can use in many use cases such as a scheduler or cron-based activity. Okay, so you may have a common piece of code and which can be exist in multiple replicas, the same piece of code, same frequency, same thing, but only one instance has to execute. So in that case, you can try to implement very easily just by matter of 2 lines of code, one or maximum 2 lines of code. With the 2 lines of code, you can achieve completely. Okay. Other than that, if you want to solve it in by different way, database, I think you know the headache and then testing and the amount of code that we want to write. It's not that pretty simple, and then we may not cover that all the use cases and all kind of fencing issues. Okay, the fencing issues. Okay, and suppose for an example, if during the processing itself one replica goes down, so what will be the impact on the second replica? Okay, so that so many logics that we want to keep track of that, or we want to build that kind of piece of logic. Okay, but Atomics provides that same. It's in a very good way. That's the reason I'm trying to use that. Even I like that Atomics very much when compared to the other. It's a pretty simple, pretty straightforward. Only thing is like we want to build a configuration. That's the only thing. That's the only challenge that I have. Okay, and even I'm trying to say that Okay, so later we will discuss about that. So this is all about this atomics and cluster locking and then cluster coordination. I pass here to take some questions if we have any, or if we missed any use cases in this case.
Hi, Brenda, Oleg here.
Yeah.
Hi, so I've tried to take a look at atomics. It seems really good, but as you said, what I noticed is this, like, let's say if you want to define a data structure of some kind, like let's say your map or your log, that actually has to be defined in the config file as well.
No.
Because
no, let me explain.
That's not the case.
No, let me explain that. That also, it's like, let me explain that particular piece. Okay, so in order to achieve a lock, you don't need any other information. So only that ID information, and other than that, the configuration information is like what piece of replica that you want to lock. Okay, just by example, let me give that one example in a Docker way and then a Kubernetes perspective. Just we can talk in that perspective. Okay. So in a Docker way, say for an example, if I want to create a 2 different or 3 different replicas, so it means like the ID, the host ID information, which is, if you try to map that name and then host name upfront, okay, if you try to define that host name upfront, or by default itself that the service name itself the host name for that case, in that case, right? So we can form, let me show an example this case. You're able to see my screen.
Brenda, I was referring not just to a log, but like, let's say if you wanted to do any distributed data structure that Atomic supports, regardless what it is, and I was not referring to just a log. It was more of just generic Atomic questions. So that, just to clarify, like what I've seen is you have to define it in an application, kind of your similar to application properties, and then that would be read in by when Atomics initializes, and then you could use that structure.
Exactly.
So is there a way to like do it more programmatically so that you would not, because my main concern is that, let's say if you wanted to change a piece of code, you would also have to do an update in config files, and that's potentially OM. It's potentially managing 3 repos that gets really annoying and slows down deployment.
Okay, let me explain. That's where we want to generate a dynamic configuration. I have seen that some examples. You are trying to say that application changes has to happen in a config file. No, that is not the case. Okay, that's case.
Good.
Yeah, that is not the case that I'm trying to say. I will try to explain that what I'm trying to explain. Okay, say for an example, I think you are able to see my screen, right?
Yes, I see your screen.
There are multiple use cases that we have. That one is, it's a multicast kind of architecture. So multicast kind of architecture, it's basically you are starting one server and then you are listening for this one port. Okay, so where others can try to join to that particular network. That is called a multicast network. Okay, so the multicast configuration is here. Okay, let me talk about that. We don't want to go for multicast network actually, but we want to go for a bootstrapping network itself. So what here, this is a simple configuration. So this is your own ID. Okay, own ID means you know that actually whenever you are trying to start a replica or you are trying to start your own instance, okay, inside that you know that what is that container name, or at least the pod name. So this is a pod name, right? So you know that pod name, and then you know the pod IP address also. Okay, the pod IP address, you know that. Okay, so this is the only information. So this can be passed from an environmental property itself. Okay, so there are so many applications of passing that pod name and pod IP, okay, to that application. So that is another thing. And another important thing, it's like, so this is another important thing that we want to generate. Okay, so this is nothing but discovery. So discovery, it's nothing but, say for an example, you are trying to have a replica. Okay, two replica. Then it means like you want to have a 2 nodes actually in this case. Okay, if you are planning to have a 3 replicas, so it means like a 3 replica. There are so many scripts. Okay, before starting the container, it creates a configuration. So in terms of understanding, oh, maybe it works in a database clustering also. Okay, if you try to look into the database clustering before starting the scripts itself, it understands that what all the pods that we have, what all the IP address we have there, what networking that we want to manage, and then all those things. So that script is already available there. Okay, so it means like based on that replica that we are trying to instantiate, and based on that replica, it creates a configuration. So only thing is we want to generate the configuration in a way, state that assumption we want to state that if you are trying to have a 5 replicas, then you may have a 5 different configuration here. If you are starting a 2 replicas, it should have a 2 different configuration here. And then the top level, it's like the self information, the self ID and the self IP address. That's all about that. So not more than that. Okay, so only that configuration we want to generate from a Kubernetes perspective, or from a Docker perspective. Docker perspective means it's like we are sure, we know that. Okay, it's like mostly the hard coded. Or some cases, what's the thing? Some cases, what you think, you always know that. Okay, I always have a 3 replicas, and I always know that the pod name should be in this same fashion. So in that case, you can simply hard code and then we can put that. So only the disadvantage with that, it's like a hard coded value. It's like whenever you are trying to scale up, okay, that it's like we want to just add a hack there. It means like we want to add a map. Either if you try to put it in a config map, then that is also not an issue. Okay, so you can try to get that IP address and then put it in a config map so that it can be easily manageable. So in that case, it is not like a more problematic one. If there are multiple options, one is hard coded option, and then you can also have a dynamic scripts. Okay, during our Kubernetes installation. Okay, whenever you are starting that, it kicks off scripts to understand that, and it generates the configuration and places the configuration in a certain place. That is also another way. And another important thing, it's like you can also manage the config map. So just by knowing that what is the container names and pod names, you can frame that configuration, and then you can update that config maps on a fly, or directly to that console. That is also possible. So what I'm trying to say is like with this configuration, only this configuration that we want to have that. Okay, other than that, we don't need that any other configuration. If you try to see that, you don't need that any other configuration, right? Any other thing that you are trying to talk about beyond this, or?
In the examples that I've seen, it defined data structure that it would be using. So what you're saying is that indeed is not the case. So the configuration that's shown here is just the cluster, then who will talk to whom, how do you bootstrap, and basically to get an idea of who the members are. And then examples that I've seen, they also mention that, okay, let's say if I want to have a distributed map, I define it in my config. So what you're saying is that as long as the cluster is bootstrapped, you could then define it in code, and it would be not needed to be defined.
Okay.
Okay, that's
so
good.
This configuration also, we don't need that. Okay, so if you try to look into that, okay, one of my implementation, let me show that. Okay, so this is another way to create that implementation. Okay, so without a configuration also, you can create a programmatic way also. Okay, so this piece of logic, say for example case, I'm creating whatever the configuration, okay, whatever the configuration I have earlier, I'm trying to create in a programmatic way also. So in that programmatic way, just I'm trying to say that what are the cluster members, only just by saying the cluster members, okay, on fly itself, then I can get this information. I can create the configuration on fly without, I don't want to look into the configuration directly there. So I have created a distributed map store. Okay, you could try to see the distributed store. Okay, distributed log, everything I have created in even programmatic way also. So in that case,
that is perfect.
Yeah, without configuration also, you can also make that. You can also do that. Okay, see here, this is the default multicast configuration. So if you want, you can alter the configuration, not only with the configuration perspective, you can collect from the environmental property, and then you can also frame that cluster. Okay, just from testing perspective, I have created that. If you try to look into that, this is.
Question, Brenda, about this.
Go ahead.
I think I look at the documentation, and I'm pretty sure Atomics supports service discovery in Kubernetes, right? Not sure if you read on that.
It's not near DNS. There is a support for DNS, but I haven't explored further because I didn't have the time. So that's the reason I'm trying to get some people, okay, with respect to Kubernetes. Okay, Kubernetes, they can how the DNS lookup which works, or even we can also integrate with remote discovery services also. So in that case, automatically it can discover and then it can do that. Okay, it has the capability. That's the point I'm trying to say.
Okay. I'll take a look on the Kubernetes site. I started
So that's
looking
the
into
reason
it.
I'm trying to say that programmatically I can create the configuration. I don't want to. In that case, if I'm able to discover that information, okay, what all the pods available and what are the configurations, okay, I want to make, I can create that. Okay, I can create a cluster on fly itself. I don't want to give it a configuration during the start itself. Okay, it depends on how we want to manage. Yeah. Okay. Just next after then. Okay, I pass here to take some questions if we have.
So one thing, maybe I missed something. So Atomics would be used. It supports clustering, and it will be used mainly to do the locking. Correct?
Yeah. Yeah. Exactly. We want to stop only stop not going further beyond the locking. Only locking. Okay. We want to do that.
Okay. And what's the use case for NATs then?
Yeah. Yeah. Exactly.
Just
Let me
sending
bring that.
messages like.
Exactly. Let me bring that NAT.
I'm not.
Yeah, NAT is so powerful. So only thing is like if I'm able to, if I have any Go developer, okay, then I can do the cluster locking with the NATs. So in that case, we don't need a Atomics itself. Okay, so it's with that NATs we can solve all the use cases. Okay, so before going to that NATs, just I want to get any feedbacks or whatever the use cases, at least whether you could solve those use cases, right? Okay, with this Atomics.
I mean, Atomics seems to be solving all of the locking issue and everything. So,
exactly.
So one thing before you continue from that, since it's 10:30, do we want to postpone or because I may
NATs we can take it in the next
meeting. Yeah, because maybe it's going to take more time. And
exactly, NATs we can take that. Just at the end, just give me 5 minutes. I will show that one example how prioritization we use that this cluster locking. Okay, Atomics locking just.
Perfect. Go ahead.
Yeah, then we can wind up this call. Yeah. Okay, so we have a message prioritization. So this may be a different microservice. Okay, it is not. It won't be a part of a blueprint. Okay, sometimes it may be a part of blueprint, but I don't want to take that load of a message prioritization. Okay, into the blueprint processor, so that we can create a one more microservice and then just include a message prioritization. So like that only we have defined in AT&T. So we have a separate microservice called message prioritization. Okay, so in this case, so how we are trying to solve? Okay, so we have multiple API implementation. Okay, just one is Kafka, one is NATS. Okay, and REST. It means like either sometimes you don't want to have that infrastructure of NATS and Kafka, so you can take it as a REST endpoint. But REST endpoint is not suitable for many of the use cases in terms of load balancing, in terms of working offlines and handling that huge number of loads, getting multiple requests at a time. So at that time, you can either go to Kafka or NATS. Kafka is a heavy weight, and then why we are trying to look into the NATS, it's like most of the functionalities are same between Kafka and NATS, but NATS provides a more functionality in terms of request supply. Along with it, it provides certain functionalities which is in a simpler manner, and the Docker size it's also 10 to 18 MB and manageable and easily clusterable. Configuration is very less in this case. Okay, coming back to that. Implementation, how we achieved that implementation, right? Message prioritization. Okay, see here. So this is a correlation system. Okay, so it means like here it has so many use cases associated with it. One important use case is a correlation. Say for an example, for a particular group, I want to listen for 3 different requests. Okay, with the same correlation key. That is a use case, simple use case. Okay, so for a group, okay, we have a different types of messages, and then each message it has to associate with some correlation. So it means like I'm running in 5 replicas. Assume that it's a load balanced scenario, and then 5 replicas I'm trying to run. So assume that okay, the correlated first correlation message of group and of type 1 lands in a first replica, and then other message of type 2 lands of the same correlation lands in a second replica. By the time I may miss that. Okay, so it means like since it lands at the same point of time with a different source system at a time, it may land in a different time. so that I may miss that correlation. Okay, so it may directly land into that and then look for the database. Okay, assuming that okay there is a no correlation key associated with that. Okay, it means like it assumes okay at a point of time for a one instance perspective, it thinks that I haven't received that message, any message before that. Okay, so that is not the that is not the case here actually. Actually the case is because it lands at the same time in a two different replicas. Okay, so it doesn't mean that I haven't received that message. Okay, so that's the reason I want to serialize that. So whenever I receive a group of a same correlation, I want to serialize, even though if it runs in a replica, okay, multiple replica, I want to serialize that. So it means like I want to process one request at a time for a particular group and correlation. So that is the reason this piece of code is a common throughout the 5 replicas. Okay, whenever prioritization, okay, the first message lands here, then automatically I'm trying to do a lock here. So what I'm trying to do a lock, I'm trying to do a lock, okay, based on the group and the correlation. So here what I'm trying to say, okay, if cluster service is available. So it means like if I'm running in a cluster mode, okay. So I'm trying to say that, okay, whether it is cluster and cluster joined everything and then correlation present, I'm trying to create a correlation key, that lock name, okay. So only this is the information I'm trying to create, okay, lock name you are trying to see. So based on the group and based on the correlation. So after then I'm trying to create a lock, and then just I'm getting that lock here. Okay, so what happens? So the lock, I'm trying to do that lock. So it means like for a same group and same correlation, if it receives in another replica also, it won't execute until if I unlock this. Okay, then I'm trying to save it in a database. I'm trying to do the correlation. It's check whether its correlation is already present or not. If it is not there, and then processing all those things happening, just I'm releasing that lock. Okay, I'm releasing the lock again. So what happens at that time? So it means like during the process, I'm making a sequential. Okay, it's not, even though if it is in a multiple containers or multiple replicas. Okay, I'm making a sequence so that it won't miss. Okay, the correlations won't miss, and then we will have a proper correlation here. So this is one simple example. Complex. How complex to implement, which can be implemented by only one line of correlation. Okay, getting the correlation, because all utilities are already implemented there in a easiest way, so that you can create a correlations based on whatever cases, or you can frame the correlation with respect to blueprint name, versions, and all those things you can try to achieve, and you can do that. And if you want to try to explore that, we have a test cases also. You can try to work on the test case. Okay, so we have a small test case here. So let me run this test case here, message prioritization service. So you try to look into that. If you try to run this test case, it tries to say that, okay, 1, 2, 3, okay, it accuses a lock 1 for this same request, and then execute, completes, and then second, and then third, okay, it tries to execute in a sequence. So it means like you don't miss. So here I'm trying to create 2 different clusters. Okay, the 2 different clusters means it's 2 different parallel processing replicas. So in this case, it's like replica. Okay, it can work. That's all I have for now. I think most probably it's like I pitched into that what I'm trying to solve.
Do you have any questions for Brenda on any of the use cases? Okay, let me stop the recording.